Alhamdulillah
Ya.
sihat. Doktor sihat?
Inilah saya. Right. Sebelum kita start session kita ni. Oh, kenapa Akilah live meeting? Alamak, mesti ada something dengan internet connection kan? Okay, for those yang dah ada dalam ni, minta sign your attendance in Putra Blast. Seperti biasa. Okay. So kita masih lagi menunggu kawan-kawan. Tiga orang lagi insyaAllah. Right. You all memang dalam kelas suka letak gambar macam ni You memang tak tunjuk muka Ke kena tunggu request daripada lecturer?
Tengah Serabai doktor, tengah Serabai.
Apa dia? Tengah Serabai. You know what? Salah satu challenge bekerja ataupun belajar daripada rumah adalah menjaga penampilan diri. Setuju tak?
Setuju doktor.
Setuju.
So maksudnya untuk menaikkan semangat masing-masing kan, make it as a normal routine. Baru you rasa ada macam semangat, oh aku nak pergi kelas. Right, so meaning to say that saya tak boleh request lah you all tunjukkan muka masing-masing ni Okay lah, I'm okay. So untuk makluman saya record kita punya session. Saya baru ingat sebab saya nampak muka Fazli. Tapi Fazli macam mana you boleh record kalau you bukan host? Fazli? Macam mana you boleh record kita punya session previous? Previous session ni kalau bukan host? Oh, add on ke macam ni? Tak apa, apa-apa pun for those yang nak record ataupun ni dalam YouTube pun dalam you punya account sahaja sebab saya tak nak ada conflict interest in the future disebabkan kita akan refer to various books, textbook ataupun journal, artikel kan dalam Google punya source ni kan banyak kan source dia. So saya tak nak ada conflict interest nanti bila dia orang macam mana entah terview ke dalam YouTube kan. Dan dia tengok ini aku punya kenapa tak minta something like that kan. So in the future kita ni kan right. So okay, saya open to all siapa yang nak tunjuk muka dia kan. Please ni. Wah, cantik lah bilik Irman. Aisyah. You punya kucing duduk luar Alamak tak dengar Aisyah. No, you unmute dulu, unmute.
Ada kat dalam bawah katil.
Biarlah dia mengacau, jangan dia mengiang-ngiang sudah
Kan dia kacau kan.
No worries. Boleh jadi kita punya entertainment Right. Okay, 17 orang. 18, 19. Dah, done. Okay. So semua dah complete. So hopefully semua dah you take your attendance untuk kita punya session. Okay, you pergi Putra Blast. Kita punya session. Sorry. Saya lupa nak. Share. Okay. So dalam Putra Blast, sorry. Tas. So dalam Putera Blast saya ada upload a few notes. Even nota yang saya share sebelum ni pun saya dah ubah sikit yang retaining structure ni. So sebenarnya kalau ikutkan kita punya you ada nampak tak? Nampak? Boleh nampak ke tak boleh nampak?
Boleh.
No, bukan nampak saya. Nampak apa ni?
Nampak.
Macam mana saya nak change layout untuk saya tengok muka you dan sambil-sambil saya nak tengok you punya apa? Yang saya punya sharing, change layout. Oh, dia kena present Right, okay, tak apa. So untuk ni, saya ada share new picture, photos. One of my project, which is if you look at here, apa yang you boleh tengok, first things first. We are talking about vertical and horizontal stress ni, right? Apa yang you boleh tengok kan?
Landslide. Okay, bolehlah cari sebab
Soil
apa boleh kita
erosion.
tengok. Soil erosion. Okay. So saya kumpul jawapan
Of soil.
Apa?
Failure in strength of soil.
One is landslide. Okay, hold on. Two is soil erosion. Three is failure.
In strength of soil. Soil strength failure.
Soil strength. Failure in soil strength. Okay. Then next, apa lagi boleh cakap? Ini apa? Kalau you tengok ni, view ni kat mana ni? Rasa-rasa agak-agak. Guess. Tak payah nak tahu alamat salah ke. Kalau you boleh nampak apa
Jambatan, Doktor.
Jambatan. Really? Sebab you nampak sini kan, jambatan. You nampak arrow ni kan nampak. Ni jambatan, isn't it? Then this one is ini kita panggil embankment embankment untuk buat jalan. Sebab ada jambatan, dia punya continuous embankment, EMBANKMENT. Macam riverbank tu kan, ini embankment. Sebab dia kita backfill pasir selected soil, kita buat embankment, atas tu untuk kita buat jalan, then after that there's a continuous with a bridge kan. Dan unfortunately kalau you tengok kat sini mungkin akan berlaku collateral damage yang amat merugikan lah sebab traktor dia dah terbalik macam ni kan. So meaning to say that the contractor kena panggil bukan forklift tak boleh angkut ni traktor ni crane. Crane kan saya rasa dululah masa saya pernah ni kan nak tarik mendalah ni kan, so berapa dah dia punya loss untuk kontraktor kat situ, isn't it? Right. Okay, so boleh saya tahu tak siapa yang pernah buat LI dengan kontraktor ataupun konsultan? Ataupun ada lagi yang tak buat lagi LI kan? Right. Siapa yang pernah buat, bukan pernah lah, previous you baru kan, dengan kontraktor ataupun dengan konsultan, more on infrastructure ke, saya tak kisah. Siapa yang pernah ada experience tu?
Saya kontraktor.
Building?
House
Building
development.
kan?
Building lah.
Okay, so which stage? Dah masuk tu?
Negeri Sembilan.
Kat Negeri Sembilan.
Ah,
Buat apa tu? Tall
Ah,
building,
house.
residential punya area lah.
Residential.
Terrace house.
Terrace house.
Masa Syah masuk tu dah stage yang keberapa? Fasa keberapa dah? Fasa apa?
Dia dah siap
dah siap.
lah. Kira macam dah infra lah, infra
Okey,
punya
maksudnya
kerja.
buat longkang-longkang, buat
longkang.
signage apa semua tu lah.
Betul.
Okay. Others? Tak ada? Oh, ramai lagi lah yang tak pergi LI.
Saya kontraktor.
Ain kontraktor kat mana?
Dekat
Terengganu kan? Dari tu kan?
Terengganu. Dekat masjid.
Buat masjid?
Buat masjid.
Buat masjid. Oh. Cik, IDP you buat projek apa masjid?
Tak Doktor. IDP
No.
buat ni.
No, the thing is, saya pernah buat ni, at least you can share with your friends yang buat masjid.
Dah Doktor tu Putri Nuzul.
Ain bagi drawing masjid dia kat saya, kat group saya.
Alright. Hard copy ke soft copy? Kalau soft copy lagi excellent.
Hard copy.
Hard copy kena scan, kena redraw sikit lah apa At least you got experience, no worries. Saya tanya ni sebab saya nak tahu you punya apa ni kan nanti saya takut saya bercakap seorang kan, bendalan ni. Saya je excited menunjukkan semua apa-apa ni kan. So the thing is kita nak balik kepada kita punya kita punya notes yang mana is berkaitan dengan vertical stress dengan horizontal stress kan. Kalau kita tengok gambar tu kan kita for the first thing saya assume because worry kenapa Dr. Nick tak start lagi mengajar apa mungkin dah minggu keempat ni kan, alamak what happened. The thing is macam saya cakap dalam previous meeting our first session minggu 1 hingga minggu ke-3 atau 4 it seems like a review stage kan, untuk you punya lateral earth pressure or you punya effective stress yang you dah belajar masa second year kan? Second year kan? Second year lah. Soal 2. So boleh saya tahu siapa yang dah buka-buka dia punya old notes? Raise your hand. Itu sebab saya nak tengok muka tu sebenarnya. Kan? Isn't it? Lupa. You all dah sembahyang, dah makan, dah lunch? Dah Dah, Alhamdulillah. Okay. So, sudah Alhamdulillah. Saya nak tanya itulah old notes tu. Tak ada orang ke? Tolong.
Belum Doktor, belum.
Belum
Doktor.
Macam mana ni? Macam mana?
Saya pun belum.
Right. Belum juga Okay. Macam payahlah, complicated lah sikit kan macam ni. Tapi you all okay, tell me, apa kalau you cakap pasal soil ni stress, bukan stress manusia stress soil. Soil stress ni, apa nama stress yang kita akan tengok ni kalau cakap pasal soil? Bagi je, Afif. Saya nak kena tahu you punya
Vertical stress, Doktor.
Vertical stress, okay, vertical stress, right? Horizontal stress, right? Inilah saya nak kena ada. Nanti saya belajar dengan Fazli lah, mungkin Fazli tahu kan macam mana nak menconteng-conteng kat atas guna monitor apa semua ni kan. Tak best lah tak ada whiteboard, isn't it? Okay. You still remember about the total stress, about the pore water pressure, about the effective stress? Ingat lagi tak?
Yes.
Ingat.
Dia datang sikit. InsyaAllah ingat insyaAllah. Right. So now we are talking about those stresses kan. Cuk, macam mana pula kaitan dengan vertical dengan horizontal ni? Alahai, semua mute. Sabar je lah. Okay, the thing is kan, sebelum kita pergi ni, I want to share with you lah, apa-apa pun kita balik kepada basic, basic of soil punya stresses ni. You kena ingat, those total stress is equals to effective stress, tolak ke campur? Apa water pressure? Saya dah bagi banyak dah tu.
Tolak.
Total stress
Tolak.
bersamaan okay. Total stress
Tambah kan?
kan? Cik. Okay, dia bersamaan dengan effective stress yang ada prime tu kan? Yang ada prime kat atas dia tu.
Tambah power pressure.
Tambah atau tolak dengan power water pressure?
Tambah.
Tambah kan? Saya tarik total stress dulu kat depan. Saya tarik total
Tambah.
imagine kan, those stresses in soil. Kalau dalam kelas saya suka lukis kan, those grain particle size tu, particle soil tu kan, those total stress and effective stress dengan power water pressure tu dia berkait dia macam mana kan. So okay, tambah, right? So the thing is sekarang ni we are talking about vertical stress dengan horizontal stress kan. So mana kita nak letak mendalam ni mana pula kan, right? It goes to either you boleh assume ataupun you boleh consider it as a total stress ataupun effective stress. It depends on condition. Tapi normally kalau untuk kita punya lateral earth pressure ni kan, kita estimate, bukan estimate, consider it as a total stress. Sebab bila kita nak consider as a effective stress, you kena consider banyak condition, right? Saya tak nak tanya, mana datang effective stress? Macam mana nak cari effective stress and etc. Those definition, those dia punya fundamental tu, you boleh buka buku, you boleh baca, right? So kat sini kita nak straightforward, kita nak pergi kepada macam mana ataupun dia punya keboleh beradaan those vertical stress and horizontal stress. So before kita pergi ke horizontal stress ni kan, saya nak tanya dulu, vertical stress ni macam mana you nak cari? Apa equipment yang you boleh guna masa you kat soil 2 punya lab? Vertical stress daripada atas, isn't it? Literally vertical kan. Macam mana, apa alat yang you boleh gunakan untuk cari vertical stress? Horizontal stress? Horizontal? Lateral? Apa lagi? Banyak buku you baca, banyak terms yang you boleh jumpa. Tapi you kena careful. You kena careful apa itu yang mana apa semua. Kalau tak nanti you confuse. Okay. Ada siapa-siapa boleh share? It is not a quiz. You cakap je, nanti saya betulkan. Kalau you rasa macam kurang keyakinan, you boleh Google je. Right. So, siapa boleh share? Tak ada? So, vertical stress, odometer. Odometer. You boleh guna odometer untuk mencari vertical stress. Ataupun you letak beban dan etc. You can convert lah. Convert to kilopascal ataupun kilonewton per meter. Meter square ke meter cube? Square, right. Kilopascal, kilonewton per meter square, right. Horizontal stress? Ingat lagi tak? Sikit lagi. Yes, shear box. Itulah shear box lah. Direct shear box, right? Direct tu sebab dia direct, right? Shear box. You ingat tu je, kan? Ingat tu dulu. Itu penting tu. Nanti you punya bos akan tanya tu, mana dapat ni, mana asalnya apa semua kan. Just want to prepare lah, right? Okay. So, saya dah go through a bit about your notes. Mengenai ini you dah nampak full ke nampak separuh Boleh saya tanya?
Baru.
Nampak
Separuh
Separuh.
Dia boleh nampak tak?
Boleh nampak lah Boleh lah sikit ni. Right. Okay. Right. Saya dah tengok jawapan-jawapan yang you dah share. A bit interesting sebab I thought ni lah dia boleh trigger sikit lah you punya ni kan. Right. So at first image kita bercakap mengenai vertical horizontal stress in water. In water. Hari tu siapa tanya saya? Haziq tanya saya kan apa beza warna biru gelap, biru cerah dengan yang kat bawah sekali, apa beza kan? Ada beza ke? Saya kata tak ada beza kan? Isn't it? Just a water, isn't it? Right. And then saya kata please give just a very simple statement. Stress or pressure, sum of both then ada hint lagi which is isotropic stress. Saya rasa mesti you dah cari apa maksud isotropic kan. Boleh saya tahu apa maksud isotropic? In a very simple layman punya statement. Ni you ada, saya rasa you ke ada yang tak explain isotropic stress ataupun hydrostatic of course lah, marah Dr. Shah kalau you tak explain kan. Okay. So someone boleh share dia punya jawapan? Apa yang kita boleh dapat daripada figure? Sorry. Nuraini?
Rasa saya jawab yang isotropic je.
Okay, one by one. Okay, Nuraini dulu.
Same in all direction.
Isotropic, same in all direction. Okay, others. Siapa lagi nak jawab? Siapa tadi? Siapa tadi yang kata nak jawab? Sama je.
Isotropic tu dia terjadi bila objek tu dalam air, dalam equilibrium
state. Alright. Same direction, equilibrium, sama kan, sama saja. Right. So if you consider kan, konon this is a drop of water drop. Kita tak cakap ada particles, soil particle inside. No. We are talking about water sahaja. Right. Okay. So sama je. Sekeliling dia sama je. Which is the same goes. Those pressure. We are talking about pressure ni. Right. Then apa lagi yang boleh explain? So some of you did explain about sama je dia punya pressure, you nak cari apa semua di kedalaman apa semua, tapi based on kedalaman dia punya pressure tu will be high lah. Sebab now we are talking about the unit weight of water, and unit weight of water pun ada relation dengan gravity punya force and etc. If you realize punya vertical stress is sama dengan unit weight of water darab dengan D, ataupun some of the books ataupun some of the saya Z. Kenapa Z, kenapa D apa semua? No. D is for depth, Z is also for depth. Kedalaman, right? And then untuk horizontal punya stress is equals to unit weight of water sama juga dengan times dengan depth, kan? Sama. Right? So to say that dia equilibrium, sama. Okay. Saya harap jawapan tu yang saya dapat nanti sebab tadi saya tengok a brief saya ada buka beberapa jawapan Okay, hopefully. Itu je jawapannya. Right? So then next, we are talking about vertical horizontal stress in water again. Tapi kat kita ada letak wall, retaining wall. Maybe some sort of gravity wall, or maybe it's just a very simple sheet pile wall, kan? Selalunya kalau keadaan ini you rasa you agak-agak lah, kat mana you boleh jumpa keadaan ini? Ada air, ada wall. Rasa-rasa kat mana you boleh jumpa?
Dam.
Yes. Awak rasa? Yelah, kawan you rasa dam. Saya nak tahu kalau Chinese cakap apa lagi in Chinese. Dam, empangan, right? Lain. Flat wall, right? Okay, I can accept that. Others? Lain. Jadi you nak buat kolam kat rumah you kan, tapi you tak boleh gali tanah. Boleh ke?
Kolah.
Kolam. Boleh. Okay, boleh diterima kolam. Okay. Right. Tapi, okay, back to the design lah. Sekarang ni kita pakai topik engineer. Right? How to design it? How to design it to make it dia tak collapse. Ataupun dia tak fail. Tak crack ke apa semua kan. Those crack things is more on the concrete punya material. Right. So kat sini, some of you give I'm not saying that correct or wrong answer sebab you ada pendapat masing-masing kan. Lagipun is kind of macam berapa 30 minit je doktor, saya tak sempat nak buat briefing statement yang simple-simple tapi padat kan. Mengejar masa. You know what, as an engineer kita memang kena diri kita bagi decision within a very short time, but based on fact. Jangan bagi short period punya ni tapi okay buat je lah, apa-apa je lah buat. No. Based on fact, and etc. Right. So kan ni kan kalau saya rasa macam kalau I give some of the value for each of the parameters, you boleh calculate dia punya point of force kan. Boleh calculate dia punya P ni. Capital P W, force of water. Kita panggil force, punya force, right? Bukan pressure, bukan stress. This is a force, right? So kat sini macam kita cakap tadi, back to the isotropic punya terms kan. Suddenly air tu dah disekat, air dah disekat. But it's only water tau, air saja. So kat sini apa yang beza dengan yang previous punya figure? Ada elemen wall, ada elemen wall, meaning to say your design sekarang ni more focus on the wall, and at the same time you want to design to make sure that this wall boleh retain water. Kalau you tengok kat sini, this droplet, saya tak cakap particles, droplet of water ni, dia punya vertical stress again sama dengan dia punya horizontal stress, but based on this figure, which is dia punya pressure distribution, kita panggil. Relate to the depth. Relate to the depth. Okay? Yang mana horizontal stress ke atas ni ataupun vertical stress ke atas ni berlainan dengan yang paling bawah. Sampai tahap manalah you punya wall tu kan. Kita tak sentuh lagi ni, ini yang warna lain ni adalah soil. We are talking about only on water. Kita tak sentuh lagi bud soil. Okay. So ada apa-apa yang you rasa macam you tak clear ataupun try to imagine the condition? Itulah. Saya baru nak tanya, this is the wall stable.
Nampak je doktor. No. Macam
Ya,
tak je. Sebab tak ada backfill kat belakang.
Macam tak ada backfill.
Tak ada backfill kat belakang.
Lain jawapan? Tak ada backfill? Sorry? Design salah, kenapa? Macam mana? Water, Oh, okay. Meaning to say that shape lah, shape ni. Okay.
Arch.
Can be considered. Others, lain-lain, apa lagi? This is just a plain view You boleh ni je, lontarkan apa-apa saja. Lontarkan apa? Throw any ideas. Tengok saya dah translate bahasa Inggeris apa je lah kan. Okay. Lain. Apa lagi? Tak ada backfill, shape dia tak berapa sesuai kan. It's not fit that condition. Others? Lagi? Cuba bayangkan ni adalah kita ambil satu condition tepi laut. Kalau kita cakap dam ataupun kolah tadi, dia punya wind, dia punya vibration tak berapa ni sangat kan. Just imagine it's tepi laut kan. You try to make it retaining wall, then suddenly ada force yang outside punya force. Lagilah akan ada, boleh ke stable ke tak wall ni, isn't it? There is so many questions that you can ask. You can ask, bukan saya, you ask yourself question. Boleh ke ni? Shape dia macam ni, tak ada backfill. Kalau ada wind punya force macam mana? Kalau ada Dr. Syah ada ajar tak olakan air apa semua? Those hydraulic. Ada kan masa you second year you belajar hydraulic punya dalam lab tu kan? Yang big punya ni wave apa semua kan? Boleh ke? Boleh kan? You tanya diri you. So the thing is, it just goes back to the design of the wall. Design of the wall. Kalau saya kata boleh, dia boleh stable. Kalau stable wall ni boleh hold the water kalau design dia memang direka bentuk untuk menahan tekanan daripada air tersebut. Full stop, habis. Kan? Tapi nak design tu you kena question lah. Boleh ke macam ni, boleh ke macam tu, material apa digunakan kan. Apa lagi? Reinforce steel apa guna dalam tu, diameter berapa steel dia, panjang berapa steel dia. Banyak persoalan. Isn't it? Right. Ni pasal air sahaja right? Kalau kita pergi yang third one, okay? We are talking about soil. Lagi complicated. Sebab dah masuk unsur-unsur soil ni, unsur-unsur tanah ni, bila masuk unsur-unsur tanah ni, we are talking about, saya bagi hint kat sini, geostatic stress dengan isotropic stress. Okay, siapa boleh share dengan saya apa itu geostatic stress? You boleh bercakap tau, saya tak nak you mengantuk. Nanti kan tak syok lah saya pula yang beria-ria kan. Siapa-siapa, boleh. You cakap je, sepatah pun okey, saya nak dengar suara je. Ni saya rekod ni tau, nanti saya tengok balik, saya bagi markah siapa yang join the session, siapa yang macam silent apa semua. Sorry, macam mana? Geostatic? Self-weight. Okay, self-weight. Okay, others? Geostatic stress.
Dia equilibrium stress tapi dia acted on soil.
Equilibrium stress tapi act on soil.
Yeah, based on the unit weight.
Okay. Syafiq ada bagi jawapan tadi. Dalam chat, isn't it? Saya nak tengok chat saya ni. Oh ni sorry. Syafiq kata, tadi Ain ke siapa yang cakap tadi? Equilibrium?
Saya.
Liana. Okay, Liana cakap.
Tapi saya nak suruh Ain buka face mask dia.
Oh, tu Ain dah buka. Kenapa Ain pakai face mask? Ain kat library ke?
Saya dekat library.
Apa dia?
Apa?
Oh.
Suasana baru.
Great. Okay. You should find, ni kan tukar sikit environment, isn't it? Syafiq kata, geostatic stress is the subsurface stresses that caused by the mass of soil itself, okay, self-weight of the mass, where there are vertical stress and horizontal stress. Wow, complete. Syafiq dapat daripada mana ni? Boleh saya tahu? At least your friends nak share juga kat mana you dapat ni. Oh, okay, right. Dia ada share link, alright. Okay. Nanti you share link tu kat sini nanti at least your friends can say boleh view lagi. Okay. Kan. Saya baru cakap boleh je share kan, nanti kawan-kawan boleh ni balik. But it's a very plain definition. Okay. So it goes back to our ni, right? Anisotropic stress. Apa? Anisotropic stress. Tadi isotropic equilibrium kan? Tadi geostatic is more on the self weight of the soil atau mass of the soil. Anisotropic, dah isotropic tu equilibrium kan, sama rata, sama ni apa semua. Anisotropic ni versus lah kot ke macam mana?
Anisotropic stress dalam underground yang tak uniform.
So it's non-homogeneous punya soil. Okay, right. Boleh diterima. Lain-lain? Just a very simple ni lah, apa yang you faham kan. Sebab sekarang ni bila you faham apa itu, ini apa semua kan, in your own terms, in your own punya pemahaman, dia lebih apa orang panggil ni, lebih cepat tertangkap. Lebih oh ini lah betul. Right? So if you are talking about soil kan, soil ni kat mana-mana you jumpa memang tak akan ada yang sama je semua. Sama maksud saya kat sini, sama jenis, sama size, sama dia punya cohesion, jelekitan, properties dia. Tak sama. Semuanya akan berbeza kan. You run the particle size distribution test kan, ingat dulu. Particle size distribution test. You tengok every single sieve tu akan ada material yang melekat kan. Right. Unless lah you memang beli satu pasir yang memang size dia sama, okay lah satu part je lah. Kat sieve yang tu je lah yang dia melekat kan. Yang dia hold, retain. Okay. So if you are talking about site kan, kat tapak in situ maksudnya di situ kat site, dia akan jumpa soil yang memang berlainan. Berlainan dari segi properties dia. So kat situ ada punya challenging untuk you design the wall if you want to create of the retaining wall kat certain location. Okay. So vertical stress again, kalau you tengok sini is equals to kedalaman darab dengan dia punya unit weight of soil. Ni tak campur lagi ada air, groundwater apa semua tak ada lagi kan. Ini baru kat tepi tepi bukit. Saya tak cakap tepi pantai sebab bila cakap tepi pantai nanti you rasa macam tepi pantai kat bawah dia tu mesti air masuk apa semua kan. No, not yet, right? Okay, thank you Syafiq. So nanti kawan-kawan boleh share tengok dia punya ni. Oh itu articles ResearchGate. Alright. Okay, nice. Right. Okay. So horizontal stress is equals to kat sini dia punya tricky sikit. Dia ada coefficient of lateral earth. Ada pemalar, ada coefficient yang you kena consider if you want to calculate the horizontal stress. And this coefficient actually is equals to horizontal stress divide by vertical stress. Okay. Sebenarnya coefficient ni adalah ratio, nisbah kepada those stresses. Yang ni hanya diguna pakai bila you consider a soil. Bila you consider a soil, so you kena ni kan, consider those coefficient of lateral earth pressure. So kat sini sebab tak ada apa-apa yang berlaku, so you can assume or you can estimate the vertical stress is the same upper and below, and then the horizontal stress is the same next to next, kiri dan kanan. Tapi vertical stress tak sama dengan horizontal stress. Ini kena ingat. So hopefully dalam you punya jawapan apa you punya yang you dah hantar tu ada merangkumi beberapa items yang saya nak ni lah kan. Based on the condition of the water and the dresser, the next one is retaining wall to the water, and then there's a soil. Kat sini saya tak letak lagi gambar retaining wall beneath of the soil, sebab nanti itu yang kita nak tengok. So if you realize in Putra Blast, saya ada share 5 parts. Lateral earth pressure part 1, 2, 3, 4 and 5. Okay. So unfortunately saya tak sempat nak record suara saya dalam tu lagi. So I think for the time being you boleh go through one by one, just a bit inilah untuk you ingat balik, sebabnya nota ni kalau siapa yang pernah ambil kelas saya pernah tunjuk nota ni dalam kelas. Okay. This is kind of a review punya mode. Okay. Itu sebab saya macam dalam masa 3 minggu 4 minggu ni supposed to you dah dig on you punya old notes, nak tengok balik apa itu lateral earth pressure, apa yang berkaitan dengan those pressures yang berkaitan dengan retaining wall type jenis apa semua. Itu memang saya dah bagi dalam soil 2 punya notes. I'm not so sure lah you simpan lagi ke tak, tapi saya bagi lagi sekali dalam Putra Plus ni, you boleh go through again, right? Ke you nak saya ni kan? Saya rasa saya boleh skip yang ni kan? Sebab saya ada a bit more ni. Yang ni kita ada satu lagi kelas hutang isn't it? 3 jam kan? Saya rasa you boleh gunakan 3 jam tu untuk you read all those 5 parts ni. Sebab saya ada bagi example sekali for each of the condition. So nanti you boleh tengok lah, I mean in terms of from the very simple one until yang not kind of very complicated tapi different condition. Okay. So untuk topics ataupun outline lateral earth pressures punya topik ni saya bahagikan kepada 4 ni lah, which is coefficient of lateral earth pressure yang kita baru je cakap tadi, yang K note K. And then the types of conditions, then there's a theories types of condition ni. You ingat lagi tak active and passive at rest? Sikit-sikit boleh lah kan? Right? Types and condition, then there's a theories. Saya ambil 2 saja yang paling utama, Rankine's theory and then Coulomb's theory. Which is those theories ni memang dia saling bukan saling bergantung, to say that saling contribute to each other. Okay, which is from the Rankine's theory, Coulomb's dapat idea, dia macam ni apa semua kan. Saya nak tanya Rankine's theory tu based on certain assumptions, saya ada letak kat situ juga. You can go through it. Sebab this is pembacaan, saya rasa macam petang-petang ni kan saya go through je apa semua kan, you rasa macam lemah longlai lah pula kan nanti kan. Anyway, it's okay you nak sambil-sambil minum air ke apa semua kan, try to refresh your body Okay. So and then at the end theories habis ni part 5 saya ada share dengan you, saya skip saya ada bagi example dalam ni, you don't have to worry. And then you also can refer to your textbook, your previous textbooks, either Craig's ataupun Brajas. Pernah dengar tak Brajas? BRAJA. Itu pun saya ada refer dalam ni. Those examples ada banyak. At least you boleh tengok dari segi variation. Tapi the target is to make sure that you know about the active, passive, at rest, and then what the theories talk about it. Okay, and then at the end. So last kali saya share about the special case. Special cases. Okay. Yang special cases ni just refer to the Rankine's punya theories. Sebab kalau Coulomb's punya theory ni saya rasa kalau you nak ambil nak go to the subject, I think maybe you can kena ambil master lah. Because it's more on a very complicated equation, and then because different condition kan, different condition. So you need to figure out, I mean in terms of how to get the lateral earth pressures ni based on those theories before you design. Okay. So saya titik beratkan pengenalan lateral earth pressure ni sebab kita akan guna dia as a fundamental before you design. Saya tahu mungkin you rasa macam cepatlah doktor, saya nak design wall ni kan. Just bagi saya wall, saya nak design. Apa yang saya nak calculate? Okay, hold on. Because you need to know the fundamental. Saya tak jamin your boss takkan tanya. Dia akan tanya. Saya cakap bos ni macam insyaAllah. InsyaAllah you akan, bila you kerja nanti, ada konsultan, kontraktor tanya ke? Tanya. Masa saya kerja dulu, saya punya bos tanya. Kita nak buat jalan ni, kita buat those backfill or embankment ni, you rasa macam mana dia punya soil or particles tu react to each other. Termenung juga saya, which is bagus juga, kontraktor pun tanya, ingatkan konsultan dia. So kalau saya tanya tu, you all boleh jawab tak apa dia? Macam mana soil dia interact to each other before and after compaction or before and after rain, infiltration occurs. So it just goes back to the fundamental. Alright. For special cases ni, I give you a few, which is there's a horizontal ground, inclined ground, and then some of the approximate solution ataupun yang rigorous solution. Dia ada in terms of you gunakan a few equation and etc. Okay. So for this one you can just go through for different and then I gave you some of examples. You boleh tengok, this is a very simple gravity wall punya example. At least sebenarnya apa-apa pun kita nak start wall kan, it just goes back to the gravity wall and retaining wall, reinforced wall. Sebab yang tu yang normally very simple and easy to design before you go to others type of wall. Normally consultant dia akan consider this type of wall because of the economical lah. Dia very economic. And then again it depends on the site. Kalau you deal with the very problematic site such as pit soil ke ataupun clay soil, you kena fikir dari segi design dia pula kan macam mana. Alright. So I gave you examples and then you just go through it also with the solution lah. Okay? Example dan solution, you don't have to worry. Okay? Those question and solution, then you can just go through it. Okay. So done about lateral earth pressure. I think you just have a very go through it again and again. Sebabnya dia punya essence adalah we want to talk about those active and passive force. Active and passive force. Force relate to the stresses lah. Yeah. Right. So at rest condition is just the method that it just goes back to fundamental part lah. Bila berlaku at rest ni dia tak ada apa-apa gangguan apa semua kan. Still need to design ataupun need to calculate it because you want to know the maximum condition, the minimum condition and also the intermediate condition of your wall. Sebab bila kita nak check kita punya calculation of wall design, kita kena consider beberapa keadaan kan. Right? So those things, right? Then if you go through your Putra Blast again, we have the retaining structure punya part. Okay, so this retaining structure, which is I put some of the introduction and then some of the background lah, more on background. But unfortunately sebab dia pun macam baca-baca je kan. Again, the outline saya masukkan sedikit background of the retaining structure, types of retaining structure and then their application. Okay, then some of the retaining wall terminology, terms dia. Then last is design procedure. Okay, the design procedure ni, okay, if you still remember your first task, your first task is to go through those standard or regulation tu kan, yang saya share dengan you ada 4 tu. Kat sini dia bermulanya kan, right? So before that, just want to highlight lah about the types ni ada banyak jenis kan, ada banyak jenis, just the matter that macam mana, dan setiap satu ni ada dia punya calculation or design lah, of course, right? Tapi yang apa dalam kita punya part ataupun subject ni, I just want to focus on this gravity walls, which is more on this cantilever, and then some of the additional of the part in terms of calculation and also design. Those parameters too are also important, because at the end of it you want to know the parameters yang related to each of the retaining walls that you use, right? Boleh ke saya minta you all hafal terminologi? Saya cakap macam tu sebab it's very important, okay? Before you want to design, of course you need to know what is what, isn't it? And so if you look at the terminology ni, kat sini contoh dia saya ambil cantilevered retaining wall. Ini saya ambil daripada buku Brooks yang Syafiq share. Ingat, ada ingat ke dah delete dah? Yang saya kata 60 pages je. Ada lagi kan Simba ingat?
Doktor nak tanya, doktor slide ni yang sama doktor?
Slide sama maksudnya? Tak, yang previous tu lain. Yang ni saya ada adjust, ada amend a few bit.
Tak, sebab sekarang kita orang dekat vertical and horizontal stress in soil lagi, yang gambar tadi tu.
Oh ya ke?
Ada daripada tadi.
Doktor. Dia dekat
Doktor change video.
Slide ni macam tak bergerak.
Ya ke? You all senyap je. Saya dah pergi sampai part 5 dah.
Doktor tengah cerita pasal terminologi.
Saya kena stop presenting, isn't it? Stop presenting and then share another one. Allah.
Doktor change window.
Saya tak suka lah Google Meet ni. Saya pergi your entire screen lah. Ada window to window. Ada window to window.
Boleh pilih kat situ.
A window.
Window.
Right? Ini. Tapi ni nanti saya akan pilih satu-satu juga ke macam mana? Lah kan kena pilih satu-satu juga. Right. Okay. You all tak stop saya. Tengok saya bercakap je. Daripada yang first tu saya dah habis sampai 4,
Share
5.
entire screen okay ke doktor?
Sorry? Entire screen Boleh? Alright. Okay then. Okay. Right, for terminology. Right. Yang ni saya ambil daripada Brooks and Brooks and apa 2010 or 10 edition 10 edition, right? So yang ni kalau you nak tengok balik lah in terms of a big view punya ni, so saya ambil daripada buku tu. Okay, so terminologi ni saya bukan nak kata you suruh memorize, but then it's better for you if you can memorize. Untuk cantilevered retaining wall ni, sebabnya retaining wall yang dia panggil cantilevered memang popular lah. Kat Malaysia ni memang kita guna lah ni. It's a very simple, and then of course it's very not saying that easy to design, but then still again, alright. So kat sini yang different daripada buku tu, saya ada tambah whip hole, whip hole, and then some of the drainage kat sini longkang, and then some of the granular backfill. They use a backfill here, but it depends on which type of soil. Okay. Yang granular backfill ni keperluan dia sebab untuk memastikan air boleh flow directly or easily to the whip hole kat sini, terus masuk ke drainage. Okay. So this part dia punya calculation for each of it tu kan ada masing-masing tu ada different parts of it. Sebab at the end of it you want to know wall kita ni stabil ke tak, and dengan slope, incline slope, then suddenly there's ada external load, surcharge load, and then some of the passive and active. Kalau cakap kat sini even the footing parts ni pun give a big contribution to the wall itself. Footing ni dia ada kaitan sikit dengan foundation punya subject. Sebab you nak cari punya ultimate bearing capacity. Still remember that? InsyaAllah QU. Q besar, Q capitals or Q small caps What's the difference? Boleh saya tahu? Senyap je. Tak apa, nanti you dig on your nota-nota foundation engineering sebab kat sini kita combine ni. Kita gabung. It's a wall and also it's a footing. Footing foundation yang paling simple sekali kan untuk you punya calculation. Alright. So ni pun saya ambil daripada buku tu, so you can just go through lah. Which is for each of the definition ataupun explanation about terminology atau terms yang digunakan dalam dalam untuk tengok. So application, some of it, yang ni pun some explanation in the books. Either one, your previous book, Craig's pun ada, you boleh tengok balik. Then some of it, design procedure ni pun saya ambil daripada books. Which is if you want to look at the design procedures, of course you need step by step method ataupun procedures yang you nak refer. So it just goes back to your first assignment yang saya bagi, talking about the standard and regulation yang diguna pakai di Europe, Britain, British standard, then some of Indians and then Malaysian. Malaysian punya rules or regulation from JKR. JKR in English apa dia? Tak tahu.
Roadwork Department.
Sorry?
Roadwork Department.
Roadwork Department?
JKR, right?
JKR. Bukan Jalan Kerja Raya.
Oh, jabatan, right?
Jabatan.
Public work.
Sorry?
Public
Yes.
work department.
Jabatan kan.
Public work department.
Jabatan, bukan jalan, Haziq.
Jalan.
Asyik jalan je, teringatlah tu. Okay. So, kita break sekejap. Then, is it possible for you to present it in group? Macam mana? Saya nak you masing-masing dah ada copy kan assignment 1 tu kan? Boleh tak kalau saya minta you present your assignment tu in group? Tapi dalam ni macam mana nak buat in group Ni mesti nanti tolak-tolak ketua je lah yang present Okay, up to you. You discuss Dalam 3:30 kita on balik. Saya nak tengok you punya presentation. Okay. Sebab habis tu saya nak continue dengan last punya slide. Last PowerPoint slide. Talking about the stability of retaining wall. Boleh? You break dulu lah 5 to 10 minutes and then after that you buka balik you punya assignment, jawapan apa semua tu, then you bagi-bagi lah siapa nak present apa semua so okay, I see you in dalam 3:30 balik you jangan risau, saya tak habis dalam pukul 5, saya selalu macam tu. Alright, okay then saya tak stop ni recording. Stop presenting. Okay, so Assalamualaikum. 3:32. Right. Lewat 2 minit. Okay, so sebelum tu pengumuman. Akila, Liana, Syakila tak ni lagi attendance, minta tick attendance untuk hari ni. Ke ada yang tak ni? Akil ke semua hadir ni saya rasa, right? Okay. So siapa nak volunteer? Group mana? Nak volunteer dulu? Boleh saya request just one group present only two? Two standard or two regulation. Yeah, you compare what is the differentiate of each code or each standard and also similarity. Ke you all nak present 4-4? Boleh pilih 2 sahaja. Okay, sebab kita nak jimat masa kat sini. Right. So, siapa nak volunteer? Kita ada 6 group kan?
Doktor 3 boleh tak doktor?
Oh, okey je. Okey, 3. Pilih 3. Saya pelik ni kalau saya nak pilih 3. No, tak kisah. Alright. Siapa nak ni? Kenapa Putri Aida left meeting? Internet problem
Dah masuk balik dah.
Dah masuk balik. Okey. Siapa nak ni? Siapa nak present? Your group. Siapa dah volunteer ni? Saya pun ni. So siapa yang volunteer, if you want to nak share your presentation pun okay je, yang you dah buat or you dah sketch or whatever. Right? Tak ada siapa nak volunteer? Ke saya nak pilih? Ya. Waiting.
Doktor present differences dengan similarities
Yes. You ada jumpa apa-apa yang pelik dalam tu? So saya minta 2 code ataupun 2 standard. You boleh present sebab saya bagi 4 kan? So I thought it should be easy for all of you lah, ataupun kalau you rasa macam, sebab saya rasa kalau nak 4-4 nanti semuanya akan ada sama lah kan. So at least you can check kalau group ni dah buat 2 and then the other group another 2, then you can check your answer tu is it same ataupun ada different big gap or whatever it is, right? So siapa nak present? Sebab dalam group tu you tak tick kan siapa ketua, siapa penolong ketua apa semua kan. Ada 3 orang je kot setiausaha. Satu lagi. Volunteer, time ticking.
Doktor dia present, semua present ke seorang je present dalam group tu?
Kalau boleh saya nak semua present lah.
Okey.
Doktor saya salah faham tadi. Saya ingat doktor nak 2 orang present. Rupanya 2 section.
2 standard je. You nak 3 present. Memang semua present lah. Tapi saya nak 2 je, 2 standard atau 2 code of practice. At least you can compare dengan your friends punya answer. I'm not so sure lah Kat. Sebelum you submit, you dah compare ke apa kan? Tapi at least you can see the difference ataupun the similarities lah. Okay, so.
Okay doktor.
Group mana dulu? Group mana
doktor,
dulu? Saya ambil markah.
Kita orang boleh dulu.
Doktor.
Group 1.
Group 5.
Group 5, group 1. Group 5 dulu. Okay?
Group 5 boleh ke? Ainan putus okey.
Kan your member your member okay? Group 5 lah. So okay, group 5 InsyaAllah. No worries.
Tak tahu betul ke tak?
Apa dia?
Tak tahu betul ke tak?
Jangan cakap gitu. Dalam belajar, istilah betul atau tak tu letak tepi dulu. Kan? You cuba dulu. Then after that kita tengoklah betul kat mana. Taknya kat mana kan. Right. Okay, group 5. Okay, group 5. So you pilih which standard or which code?
Sekejap, Nisa nak share screen ke? Sekejap doktor, Nisa dia share screen.
Boleh, boleh. At least your friends also can have a view.
Nisa, unmute.
Ni, Nisa share screen je. Orang lain yang bercakap.
Dia lari dulu doktor.
Okay.
Nisa scroll sikit. Doctor, we didn't decide on which code. Can we just... Okay, so
just pick lah. Pick two.
Pick two. Putih nak yang mana?
Indian dan JKR.
Indian dengan Malaysian Okay, so you pick Indian and
So for the difference, we have 4 aspects in terms of general, the type of retaining wall, the design criteria, and also the factor of safety. So we identify each code aspect. So balik. Okay, for focus on Indian standard and JKR. So in general, for Indian standard, it consists of 10 parts, which part each mainly focus on retaining wall only. For JKR, it is used as a supplement to other geotechnical manuals, such as Geotechnical Manual for Slope published by John Home, British Standard, and other accepted standard practices. That one is for general aspect. For the type of retaining wall, as you can see at the screen, these are the difference in the type of retaining wall for each code. For Indian standard, they have dry stone walls, banded dry stone walls, cement stone walls, gabion walls, RCC crepe walls, timber crepe walls, and into more. For JKR standard, consists of contiguous pile, RCC wall and micropile, RC wall and sheet pile, and other type of retaining wall. You can see that there are different in terms of type of retaining wall for these two codes. So for next is for the design criteria. For Indian standard, in the evaluation of design on the surface of the building structure, the lifted and enclosure, the earth pressure, the water pressure, seismic force, and special loads. So the design of the structure to withstand these loads and pressures, that one is for Indian. For JKR, the design criteria focus on the basic soil properties, chemical properties, consolidation parameters, shear strength parameters, and also the groundwater level. So the last aspect to compare is the factor of safety. So for the Indian standard, this one we only pick from what they state in the code. So for Indian standard, they said that for against overturning, the factor of safety must be larger than 2 for static loads and larger than 1.5 for earthquake. For against sliding, larger than 1.5 for static load and more than 1 for earthquake. For against flotation, must be more than 1.25. For JKR, they mentioned that the minimum global factor of safety for treated slope shall be 1.5, and all untreated field slopes and embankments shall be designed with 2 meter width and 6 meter height with a minimum factor of safety of 1.3. Okay, that one is for the difference. For similarities, this one is for all the 4 codes. So all codes and practice guidelines above are used to design a retaining wall by providing guidance to the engineer. The objective for all codes is to increase the stability of the design slope and minimize the risk of slope failure. Another similarities is the code use the same similar term while analyzing the soil strength and stability of the slope. For example, the clear symbol, the effective cohesion symbol, and the active earth pressure coefficient. And last similarity point is all codes and practice guideline above study the existing typical of the cross-section of the slope features before proceed with the slope design. That's all.
Okay. So any additional info from your friends, from your members? Tak ada. Putri pun tak ada nak cakap apa?
No.
Tak ada. Ada pun. Okay. So next, saya tak nak komen apa-apa lagi. Kita kumpul dulu Right? Next group.
Grup 2 boleh dah tak?
Group 2, okay.
Boleh tak?
Tadi group 1
Boleh dah tak? Grup 2 boleh dah?
Group 2 lah.
Boleh dah.
Tiba-tiba dia rasa datang berdebar gitu
Okay, kami yang kedua kan. Okay. Okay. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. I'm very good evening to all. So we are from group 2. We will present the different similarities between two codes that we choose is the Eurocode and the British Standard. Okay, so for the first two, which is for the in term of overall, British Standard, the code is primarily applicable to small and medium walls with a retained height of up to about 8 meters. Although many of the recommendations are more generally applicable, but for the Eurocode is summarizing the general rules, basic design principles, and design methods for geotechnical design according to Eurocode. EN 1987 is concerned with the requirements for strength, stability, serviceability, and durability of structures. Other requirements such as thermal insulation or sound insulation are not considered in EN 1987. For seismic design requirement, EN 1998 should be referred as it provide additional rules. So for the second one is for the pipe, which is in British Standard, it divided into 4 sections, which is the section 1 is briefly explain regarding the term use and factors influencing and charge of retaining wall. For the second section, describe site and geotechnical data required together with material properties. For the third section, identify the design philosophy and the design methods for each retaining structure, including earth pressure and analysis of equilibrium stable. Lastly, for the section 4, explain in detail various individual types of structure and application of earth pressure with methods of construction and maintenance. For the Eurocode, we didn't find any part, but I think the part is for the EN 1997 and EN 1998. Okay, so for the third one is in terms of code. For the British Standard, we didn't find any code, but for the Eurocode, for the British Standard, we didn't find any code. But for the Eurocode, we found that EN 1997 7-1, it also gives the design guidance and action for geotechnical design of buildings and civil engineering works. And for the second code is EN 1997-2, which is covered the ground investigation and testing for geotechnical design. Next, I will pass to my partner, Mr. Shafiq. Thank you.
Okay, Assalamualaikum, my name is Shafiq. I will continue the factor of safety for British Standard. There are 3 approaches in determining factor of safety for embedded retaining structure. gross pressure method is when angle of shearing resistance is 0. The factor of safety is 1, decreases with increasing depth of penetration. For stiff clays, soil's larger factor of safety is to prevent of the wall. For net pressure method, based on horizontal pressure distribution diagram, which derive from active and passive pressure, equivalent to lower factor of safety to gross pressure. The next method is N-fixity method. Assumption on fixed earth support condition for pile wall embedded in sand. Factor of safety is 1. Okay, for Eurocode, the factor of safety is Okay, for the factor of safety is based on partial factor of safety applied on load. The code is 1919 for state case D1A. There are 2 load, permanent and variable, and each permanent and variable have 2 favorable and unfavorable. As you can see the value here. However, based on the Eurocode that given by shared by our friends, the global factor of safety was by Okay, then the type of retaining wall, British standard, they are gravity as concrete, simple form battered face, battered back, step back, and battered masonry face. Gabions, large cages or basket, usually steel stone to creep work, alternative to concrete and masonry mass gravity wall, and reinforced concrete and reinforced masonry walls on counterfort, buttress, reverse, cantilever, precast retaining wall, and we have embedded wall, which is the cantilever, also known as sheet walls, built of contiguous interlocking individual piles or diaphragm wall panels to form a continuous structure. We have soldier or king diaphragm wall soldier or king piles, consists of vertical members built in suitable center with a system of ground support. We have strutted excavation and cofferdams and waterfront structures. For Eurocode, the type of retaining wall used is reinforced concrete retaining wall, mass retaining wall, sheet pile retaining wall. So there is not here, EN 1997 does not cover reinforced field as all will follow their national standard. Like example, UK use their British standard. Then I'll pass to Haziq.
Assalamualaikum. So I will explain about the design criteria and the surcharge. So for British standard, the design criteria is basically based on the design of a retaining structure by considering the interaction between ground and the structure. So the 2 sets of calculation with equilibrium calculation and structural design calculation are required to determine overall proportion, geometry, size, and properties of structural section. So for the Eurocode, the design criteria is divided into 2 categories. The first category is for the small and relative simple structure with negligible risk, while the other one is for conventional type of structure with no exceptional risk or difficulties in soil or loading condition. So for surcharge, for British standard, there is an obligatory minimum surcharge of 10 kN per meter square to be applied to the surface of retained soil in the design of retaining wall. Various surcharge imposed on a structure may be classified as PDL, continuous load on the surface, concentrated load, column footing, line load for street footing, dynamic load for traffic and impact load. However, for British standard, we haven't find any yet. So for the question, also we didn't have any information details for Eurocode and also British standard. So we proceed to similarities. However, there are 3 similarities between Eurocode and British Standard. The first one, two similarities between Eurocode and British Standard. So the first one is Eurocode 7 and British Standard 8002/1994 both verify and define that the type of retaining wall in the construction of the retaining wall. The second one is the limit state and ultimate limit state in the design have been verified by both Eurocode 7 and British Standard 8002/1994. So that's all from our group. Thank you. Any question? No question. Okay, Shakila next.
Okay, stop presenting please.
Apa?
Mana Syafiq?
Doktor mute.
Oh iya, doktor tengah cakap.
Saya bercakap tapi maaf. Group, saya tanya group mana?
Saya, sekejap.
Group 1.
So Syafiq dah stop presenting.
Okay.
So you want to present?
Dah. Okay. Assalamualaikum and good afternoon. So we are from group 1. So kita orang nak present British dengan JKR.
British, BS dengan JKR okay.
So the first one is for the differences of each of the code of the practice. So for the general, for British, it applicable to small medium walls, which retain height up about 8 meters. And for JKR, it used for slope design and other relevant technical guidelines such as the Arahan technique. And then next we have type of retaining walls. For BS, we have gravity walls, reinforced concrete walls, embedded walls, and others like strata excavations, confer dams, and anchorage waterfront structure. And for JKR, we have contiguous board pie with reinforced concrete wall, creep wall, gabion wall, and then horizontal drain, rock fill, soil nailing, and fencing. So for the site and geotechnical data required for BS, we need to have the topography of the layout of the site, and then the details of the foundations and the nature of the ground and water conditions, and the tidal and seasonal variations. And for JKR, for JKR, we need the SI investigation, site investigation report to know all the details. And then for the soil properties data, for BS, we have effective stress, total stress, stiffness under both drain and undrained conditions. And for the JKR, we have basic soil properties, chemical properties of subsoil, and effect to the foundation structures, consolidation parameters, compression, and then we have shear strength parameters, and total stress strength, and the groundwater level. So for the design philosophy, I'm passed to Shakila.
So for the design philosophy for BS, it's based on limit state design, include ultimate limit state and serviceability limit state. And then design value of parameter, applied load, design soil strength, design value should not exceed, and the last one design exposure. And for the JKR, it's based on shear strength parameter, which include effective stress and total stress strength. For the design method, for BS, it's based on equilibrium calculation, design situation, calculation based on total and effective stress parameter, design using total stress parameter, design value of wall friction, base friction, and undrained wall adhesion, and last, design to structural code. And for the JKR, the design method is based on geological mapping and investigation, earthwork, settlement analysis, and slope stability analysis. For the factor of safety, for BS, just one for the retaining wall embedded in sand, which is Tezagi said the factor of safety is 1. And for the anchorage system and individual members should not be less than 2. And I found it at the last page. I think basically the size of the factor of safety used in design is dependent on which method of design is used. For JKR, it adopted factor of safety from international standards such as Geo Hong Kong and British standard. I will pass to Daniel.
Hi, Assalamualaikum. My name is Daniel Samsudin. So I'll be explaining on the similarities between all of the standards. As you know, for the similarities that we've found out is that all the 4 codes and practices and guidelines are using the same terms. For example, for effective cohesion, for effective angle, and for active earth pressure coefficient. And for the objective, of course, these guidelines are there in order for the designer to design the retaining wall, and also the objective applied by all 4 codes and practice guidelines is to increase the stability of the design slope and minimize the risk in the slope failure. We don't want the designer to build the retaining wall to fail. You know, we don't want the designer to fail. So the guides are there for designer to refer. And for lastly is what are the factors that affecting the choice of retaining wall. For all the 4 codes, they stated that, or somewhere in all of the 4 codes, they stated that is important in order to know the location of the wall, firstly, and secondly, propose the height of the wall. Third, this is the most important, is the ground condition. We must know the soil strata, the soil behavior, the bearing capacity, and last but not least, the groundwater and tidal condition, the extent of ground movement acceptable during construction and in survey. For example, if you want to build a retaining wall beside the sea or beside the highway, so all of these factors will affect the choice of retaining wall that the designer are going to choose. So that's all from my group. Thank you for listening and have a great day. Thank you.
Okay then, thank you. Next group.
My group, Doctor.
Which group?
Group 4.
Group 4, eh? Okay, so which standard or which code of practice? Group 4, group 4. Mana? Nak compare dengan mana?
Eurocode and BS.
Eurocode dengan BS. Okay.
Nampak tak?
Nampak, clear.
Nampak.
Okay.
Start.
Start.
Okay, Assalamualaikum everyone. We are from Group 4. So the similarities that we obtained between the Eurocode and BS is, the first one is JKR standard can be used as supplementary guidelines to other technical guidelines such as British standard, as mentioned in JKR standard in page 8. And the second one is both Eurocode 7 and BS 8002 1994 has explained and specified the types of retaining wall in designing, as mentioned also in BS standard in page 37 and Eurocode 40. The third one is both Eurocode 7 and BS 8002/1994 has explained the limit state and alternate limit state in designing, as shown in page 18 and page 40. Next one, I will pass to Jannah.
Okay, for the differences, for Eurocode, it summarizes the general rule, basic design principle and design method for geotechnical design. And then for BS, it summarizes the design and construction of structure to retain soil and material with similar engineering properties. Okay, next, it comprises an overview of Eurocode 7 with focus on the design requirement, action and design situation and limit state. For BS, it provides guidance for a designer conversant with theoretical and applied soil mechanics and experience in structural design and construction. Okay, next, for Eurocode 7, it comply with EN 1997 1997/2 and 1997/1. For BS, it comply with BS at 002/1994. The structural design of the steel sheet piling should be in accordance with BS 449 Part 2. Okay, next, Ain.
Okay, next, for BS, for Eurocode, its composite retaining structure are wall composed of elements of the above two types, which is gravity and embedded. And for the BS, type of embedded retaining wall are prop wall, cantilever wall, and anchor wall. For factor of safety Eurocode, do not mention, but for BS, for selection of earth retaining structure, it depends on location of the wall, position of relative wall to other structure, amount of space available, proposed height of the wall, topography, before and after construction, ground condition, groundwater, in services, effect of movement of retaining structure, life loading, available material, appearance, and required life maintenance. For factor of safety for Eurocode, it's not mentioned, but for BS, it's mentioned for embedded in sand. Factor of safety is 1, based on Terzaghi 1943, while for anchorage system, an individual member should not less than 2 according to BS 8081. Why factor of safety used in design independent on which method of design is used. That's all for differences and similarities from group 4.
Okay then, thank you. So next,
Group 3,
group 3.
Doctor.
Group 3.
Tiga.
Right, which code do you want to share with us?
We wanted to share on the difference and similarities between JKR standard and Indian standard.
JKR and Indian standard. Okay. Siapa nak share ni?
Cara kita tengah try je.
Okay.
Nampak? Macam nak share?
Tu lah yang kat bin apa titik 3.
Present now tu.
Present now, sorry. Tu more options.
Okay. Dia present your entire screen kan? Tak boleh share lah, sorry lah. Sekejap Macam mana tengah share ni? Button share ni tak hidup. Sekejap, ada orang lain tengah present ke?
Tak ada ni kan? Tak ada. So sepatutnya okey je. Siapa lagi? Kok ada member yang boleh ni share kan? Mesti the same same document supposed to.
Okay, so we're going to present about the difference and similarities between JKR standard and Indian standard. So based on the scope of work, the JKR standard are intended to be used for slope design and complement other relevant technical designs such as arahan teknik jalan. So this standard also used as a supplement to other geotechnical guidelines. So the design guideline of JKR standard was prepared by Slope Engineering Branch Jabatan Kerja Raya Malaysia, so that it provide assistance in the designer to design an assessment of slope stability, safety and mitigation. On the basic design criteria and the scope and the methodology used for JKR standard, the first thing is the feasibility study, which they review on the historical data or records such as design report, as-built drawing, survey data and SI data. Next will be a survey data which requires a topographical, hydrological and land survey. And the third one is a site investigation, where they undertake a soil investigation and material survey. All the site investigation works should be complied to British Standard and Geo Hong Kong Guide to Site Investigation and JKR specification. The next one is the engineering geological mapping and investigation, with geological mapping of subject area should be carried out at appropriate scale. Next one is independent check on slope stabilization, which all geotechnical design should be independently checked by independent geotechnical checker. Next one is earthworks. Under this section are for fill material, which material used in construction of field and embankment should just excavated from adjacent carts. And the next one is settlement analysis, which settlement analysis should be carried out for the field slope and embankments depending on the subsoil condition. And the next one is engineering analysis, which slope stability analysis are obtained. Analysis including the execution design criteria and the performing calculations such as cart, field and natural slopes. And next one is for rock slopes, and the rock slope is preliminary consideration can be used. Next one is cut slopes. All untreated slopes should be designed with minimum of 2 meter berm. Next one is field slope and embankments. And the next one is drain, where surface drain and subsurface drains are considered. And the last one is reinforced structure, which reinforced structure should be designed according to the British standard, and their geotechnical design used for geotechnical works are designed according to the factor of safety shown in the table 6 in the standard. Okay, that's all for JKR standard.
Okay, now we continue the presentation on Indian standard. Okay, as for Indian standard, I will summarize the standard. Actually, Indian standard is a design guideline on choosing the suitable retaining wall for hill slopes. Actually, for Indian standard, they are choosing the retaining wall based on the type of construction. What is the construction requirement? So there is not actually a rigid guideline for Indian standard. They are using the standard actually based on the type of material used, the type of construction needed, what are the method of the construction, something like that. Okay, but the Indian standard also they must follow the allowable bearing stress in accordance with IS 6403. In order to choose the retaining wall, the suitable retaining wall, they are using the Indian standard 6403. And I will explain briefly regarding the basic design criteria for Indian standard. on retaining wall. Actually, the the type of retaining wall is choose based on condition such as type of construction, the mechanical behavior, the local resource. Actually, local resource regarding like what are the skills presented by the people on that site. Right, the local resource actually is what are the resource on that particular site. Right, to establish the retaining wall, they need to know this the local resource that is available on site, and also the seismicity of the region. Seismic is something like regarding like earthquake or earth movement, so they need to know this in order to construct the retaining wall. And also they take into consideration on loads. Okay, what are the loads, like live loads, dead loads, right? This particular load is needed to in order to design as one of the design criteria for the retaining wall. Because if we do not know all these loads, so then we do something like there is no particular guidelines, right? We are waiting for the project to fail because we don't know the exact loads, all right? And also we need to take into consideration of the depth of walls, right? The drainage and the erosion control, right? All these are under Indian standard. And most important thing is the stability of the retaining wall against loading, right? And as for the similarities for Indian standard, there is no similarities between Indian standard and JKR standard, and also British standard, Eurocode 7, and so forth. Because this standard is actually depending on the construction condition, right? So it depending on the construction. So I think that is all for me. Thank you.
That's great. Okay then, thank you very much. So last, final group. Group 6.
My group. Group 6, Doctor.
Group 6. So which code do you want to compare and find the similarities?
Rabi. Where Rabi? Rabi?
Sekejap. Rabi dah share. Okay. On off, okay. Then. Betul dah ni,
Gerak ke?
Tak. On off je.
So okay.
Okay.
Okay, basically this is the comparison between British standard and Eurocode 7. So the similarities is British standard requires a minimum allowance for unplanned excavation, which is 0.5 meter. Same with Eurocode 7 with maximum 0.5 meter. So after that, British standard supplies recommendation for the design of earth retaining structure, whereas Eurocode 7 describe how to design geotechnical structure using the limit state design philosophy. So next one is the difference. So I start with British Standard. So British Standard impose a minimum design surcharge, whereas the Eurocode 7 does not impose a minimum design of surcharge. And then British Standard show a detail about retaining wall design such as cantilever wall, counterfort wall, and so others. But in the Eurocode, it not specifically shown about the design of wall. So after that, the standard also give further details on how returning structure should be designed according to limit state principles and provide information missing from Eurocode 7 but of importance to UK practice. After that, it's British Standard supplies additional information to Eurocode 7's recommendation for surcharge, unplanned excavation, and prop loads. Okay, from Eurocode 7, the difference is Eurocode 7 use unit factor for serviceability in limit state. After that, Eurocode 7 show a partial factor at the retaining wall design such as reinforced concrete wall, mass gravity wall. After that, Eurocode 7 does not cover the detailed design as I mentioned. And then lastly, it provides a broad framework for the design of all different types of geotechnical structure, giving many list of items to be considered, taken into account, or checked in a geotechnical design. Okay, that's all for me.
Okay, next I'll be presenting my part. I'll do the comparison between JKR and British Standard. First, the similarities between these two codes is both codes and guidelines practice the same methods to determine the factor of safety. It was stated in JKR guidelines that the methods that they use to determine the factor of safety following the British Standard. And the differences is first for the JKR, the drainage is constant whether the water pressure should be factored or not. The water level behind the retaining wall will be the decision to the factor of the design situation. And for the British Standard, the drainage covered in this surface drain and subsurface. Next, the differences is it does not impose, for the JKR, it does not impose the minimum drainage surcharge, but in British Standard, it imposed the minimum design surcharge. And for the JKR Standard, the guidelines covered regarding the soil and the slope stabilization method. And for the British Standard, it covers regarding the retaining wall design such as the cantilever wall, counterfeit wall, and buttress wall. Next, I pass to Rabi.
Okay, for the Eurocode 7 and JKR, the similarities is the site investigation, geological mapping investigation method carried out, and also the design soil parameters by the field exploration and laboratory investigation. And then for the differences, for Eurocode 7, it is for the geotechnical design that summarize all general rules, basic design principles, and design method of geotechnical following the Eurocodes. For the JKR, intend to be used for slope design based on current technical requirements, design materials, assessment of slope stability, safety and mitigation by complementing existing design policies, manuals, and directives recognized by JKR. And also for Eurocode, it explains the design of gravity walls, embedded walls, slope stability, supervision, monitoring, and maintenance. For the JKR, it explains the soil slope
stabilization method and road slope stabilization method. For Eurocode, it's design involving the ULS, SLS, and partial factor situation, and also slope stability focusing on retaining structure, excavation, slope, embankment, foundation, and etc. For the JKR, geotechnical design criteria for geotechnical work are shown, and slope stability focusing solely on slope design, and slope stability analysis required for all cut, fill, and natural slopes. And also overall slope stability analysis for Eurocode is focusing on the relevant limit states, and also verified the overall moment and vertical equilibrium of the sliding mass. And for the drainage, for Eurocode, it's concerned on whether water pressure should be factored or not, and water levels behind the retaining walls will be the decision factor for the design situation with or without reliable drainage. For the GKR, the drainage consists of surface drains and subsurface drains. That's all from our group. Thank you.
Okay then, thank you. It seems like your group has summarized all of it. Thank you very much anyway. There's no right or wrong actually, okay. But then it just it's a good reading, and then you know exactly. I mean, in terms of each of the country that you will refer to, there's a different codes and there's also similarities. But yang saya nak tegaskan kat sini apa-apa pun, which is there are 4 things that you need to consider, the main things, which is it covers in a general scope tu, which is covers those site investigation, those strata, whatever it is lah, and the means that location and the type of either rock or soil, etc. Then type of wall, which is apa yang you nak kajikan, and it seems like British standard tu seems giving a lot of examples yang you boleh refer to, then some of part of the design criteria, and then of course the main thing is factor of safety lah. It seems like Indian punya code tu you tak siapa yang cover ni tak explain about factor of safety. They just refer to other standard, which is actually the main focus. The factor of safety tu the main parts lah. You dah design apa semua kan, of course you nak tahu design ni safe ke tak, and at the end of it, right? And then some of additional items ni yang sekarang ni memang menjadi favorable, which is more on seismic and earthquake. Even though it's just like a very simple retaining wall, maybe just a very lebar, tak berapa lebar sangat kan, but then whatever it is, you need to design it properly. Okay, so macam yang saya janjikan tadi, okay, so it's done. You all tak ada nak argue masing-masing mengenai apa yang you dah compare, apa yang you dah find those similarities, etc. Actually you are the masters now. You dah master those coding, those full codings. Siapa-siapa yang nak tanya you lepas ni boleh refer to directly to you, right? Okay, so I want to share some last part, which is the talking about modes of failure. So tak ada siapa share ni, sebab saya share kan, right? Okay, modes of failure kan. Sebab tadi we talk about those lateral earth pressure, active, passive, at rest. So at the end of it, of course lah, kita nak implement or apply those stresses in the application part, which is application part kat sini yang saya nak tegaskan. You want to check the factor of safety against of those 3 things. Yang ni yang paling utama. Overturning, check for the sliding, and check for the bearing capacity. Some of the codes, it seems like they just focus on the overturning, sliding, and then some part of the, in terms of the structure itself. Tapi yang major part is should be covered these 3 codes lah, these 3 checking, right? Yang ni you boleh and bearing capacity, and some covered by the deep-seated which is more on the bearing capacity part lah kan. Those deep-seated ni dia combination dengan apa, those settlement, right? Apa yang saya nak highlight kan, ini nanti boleh baca lah, in terms of the explanation of the modes and etc. Okay, so talking about the apa, overturning, checking for overturning, right? You can go through, in terms of, as I said before, we want to focus on the gravity war kan, retaining wall dengan gravity war. Yang ni yang paling easy for you to digest actually. There's a lot of examples regarding the apa type of wall and etc. But then of course you need to focus on each part of it kan. Saya ambil apa this part because it's easy for you to look at and then to compare. Okay? So for the cantilever and then for the gravity retaining wall. So nanti bolehlah compare kan pula mana apa which part and etc. But then the main essence ataupun important points is those three checking yang you nak kena check as a apa engineer. Tadi as a designer saya nak kata as an engineer. You are engineer. Designer is more on architect, right? You are engineer, so you want to engineer whatever that you want to construct based on the rules, right? So those checking for overturning, of course, there's a lot of apa equation yang you boleh refer to, macam dalam coding, apa standard and code of practice tadi kan, they lay out everything. So in terms of examples, equation apa yang berkaitan dengan apa-apa, but it just goes back to the what do you want to calculate actually. The passive active force, passive force, at rest force ada ke? Ataupun just active or passive kan? Tengoklah mana-mana yang you nak ni kan. So in terms of the procedure, so saya letak juga kat sini. I don't want to go in details because it should be the similar way of calculating which is in the previous notes I just shared with you. It's just the method that you want to cut the parts lah. Nanti boleh nak tengok macam mana sampai maybe until apa kalau kita tengok sini. Those cantilever ni only got 5 parts, but then for gravity wall got 6 parts. So you just need to focus or specific which design that you want to checking ataupun nak calculate, right? So check for overturning, then check for the sliding, okay? Then you just go through each of it. Yang ni notes saya ambil daripada Braja MDAS, right? And some part of it is from the Craig, okay? Craig, right? So for sliding, for the overturning, they have the factor of safety that you need to follow, all right? For which part that you want to checking. Factor of safety for sliding, that's is minimum. This is minimum, meaning to say that above that okay, very safe. Tapi minimum lebih kurang daripada 1.5 means that you need to redesign again. Redesign meaning to say recalculate again. Which part that you need to to amend or to modify. Mungkin base dia or footing dia tu kena panjang sikit ataupun kena lebar sikit ke, kena kecilkan sikit and etc. Those wall pane, wall tu pane tu, you kena check jugalah. Mungkin ketinggian dia ke atau apa semua kan. Those design procedures that I've shared with you in in the previous slide of background for the retaining structure. Yang kat situ those design. Ataupun you boleh refer to Brooks punya book, design criteria or design checking. Okay. Then at the end of it is a bearing capacity failure, which is this bearing capacity failure. Yang ni yang you kena refer balik you punya foundation engineering punya nota. This is more on ultimate bearing capacity for the soil itself. So of course it relates to the calculating of the footing or the foundation to the towards the soil. So kat sini we want to highlight the maximum and minimum pressure. Ini yang you kena calculate. Okay, so talking about that, maybe you find out some of the terms like eccentricity, those the distance from the E and etc. So you yang tu you boleh refer balik pada you punya foundation punya notes, alright? So again, checking about the calculating for the vertical force and the moment, resistance and etc. Okay. The rest is something like follow to the step-by-step things actually. Okay. Factor of safety for bearing capacity, normally we refer to FOS equals to 3, right? Because it's near to the foundation punya factor of safety. So kat sini saya share some of examples and retaining wall, cantilever retaining wall. Then of course with their solution, cover the factor to find out the checking the overturning, checking the sliding, and then checking the bearing capacity, right? Which is either safe or not. So you kena tengok balik those factor of safety yang refer to each of the condition, right? So then, so yang ni I don't expect any question yet, but then of course I will let you go through the notes. Okay? So you are open to ask any question in our WhatsApp group. Macam saya highlight in our first meeting. Even though I put there Monday berapa-berapa kan, tapi it's open. You boleh tanya bila 8 to 5 lah. Jangan sampai malam, right? So just read it, digest it slowly, because of course whatever it is, this is more on calculation part. Tapi calculation bukan calculation yang you bantai je apa semua. No, it must be referred to something which is a factor of safety. At the end of it, you nak check factor of safety dia selamat atau tak. And then I want to share you something, right? Because if you go through your Putra Blast again, I just include, yang tu macam mana sekejap saya nak tanya. I include some of the assignment. This assignment ni 1 week. Assignment ni sekejap je. Individu. Okay, individu assignment. But then, of course, open lah you nak discuss among yourself and etc. So, sekejap. I want to check. So Putra Blast, okay. Under retaining structure, boleh nampak Boleh So under retaining structures punya division ni, okay, I share with you some of the spreadsheet template. Alamak, saya ni pula. Okay. And then there's a assignment here. I give an example. Then I want you to what do you call that? Not combine. Bukan format. Apa? Sebab calculation tu you buat manually kan? So sorry? Yes. It's not that masukkan balik. I want you to come up with your own flow. You ikut je sebenarnya kan, based on example tu. The first part is of course you need to find out those properties punya earth pressure, stresses and etc. Then second is you want to check the stability of the retaining wall. So saya nak you masukkan dalam spreadsheet ni, make it an a very nice equation. Bukan you make it the equation tu dah ada, you just masukkan dalam spreadsheet, then you put it in a very appropriate punya step by step things. Sebabnya yang tu kan sebenarnya you boleh cari lepas ni macam mana how to include those examples in the spreadsheet. Sebabnya bila you kerja nanti, this spreadsheet yang you akan guna sepanjang masa if you work as a consultant, even though as a contractor, you akan tengok balik macam mana consultant you design macam mana kan. You akan gunakan this spreadsheet to calculate again and again, right? So we try to save our time by formatting it, or by using the appropriate equation in the Excel file. So lepas tu you bolehlah design banyak-banyak based on different soil properties, different wall punya dimension, and you boleh ni. At the end of it, you want to check either the factor of safety for each of the criteria tadi tu lulus ke tak, pass ke tak, those factor of safety. Okay, so this I want you to make it individual punya part. So nanti you submit here, I give you 1 week, but then of course make it in 1 week. Just try to make it 1 week, and it's very simple ni. Then you can just refer to the example. So I hope walaupun example tu sama je kan semua, I hope you try your best to do it your own first. Masukkan dalam spreadsheet tu, masuk dalam Excel apa semua tu, those equation. Then after that kalau you tak faham, you boleh discuss. Tapi apa-apa pun saya nak you buat sendiri. At least you have the experience to do it by your own. Okay. I'm not saying that you are allowed to copy or etc. But then it's not dah tak wajar lah untuk copy assignment kan, dah fault dia kan, isn't it? This is at least your own experience. So the thing is at least you can figure out lah. This is the way that engineer work. Nanti bila dah kerja macam ni lah. Kalau especially if you work in consultant, you mengadap how to design etc. Then once you complete this one, nanti saya akan try to polish more by using different type of, nanti kan kita dah nak masuk ke jenis-jenis retaining wall. Setiap satu tu berlainan dia punya calculation, setiap satu tu approach dia or parameters dia pun berlainan. At the end of it baru kita selitkan penggunaan software kan. Saya tak nak terus you guna software, nanti you dah rasa kemudahan dia, kesenangan dia kan. We start with the manual first. Manual tu sebenarnya manual calculation, we just begin it in a soil 2 punya ni. Tapi tak apa, saya bagi dah example solution, you try to buat latih to be. Buat latih to be banyak-banyak kali buat ni. Then after that guna spreadsheet. Kalau you ada masa you boleh guna buat untuk setiap example. But then I just want you to use that spreadsheet only for that assignment, satu sahaja. Then after that kita akan guna software. Penggunaan software ni memang bukan a bit, it's very interesting. Different software, different approach, different how to handle it. But then of course, whatever it is, you need to know the properties of soils and then the properties or the dimension of the wall and the type of wall. Macam those Eurocode, those BS, Indian standard is paling simple sebab I think they just try to make it easy and then try to make it sebenarnya it's not easy, sebenarnya they try to make it complicated kan. It's open, lagi tak teratur dia punya tu lagi complicated. You punya yang boleh refer, isn't it? JKR punya ni is more on our Malaysian punya condition lah. You don't have to worry about it. It's just the method that try to compare and find the similarities. Alright, so any question before we dismiss? Not yet?
Not yet.
Not yet?
Not yet.
But then of course you are open to us in our group. Kalau terlalu malu boleh personal message, but then I prefer at least in a group, at least semua orang tahu apa persoalan dia apa semua kan. There's no right or wrong in questioning or throw out any question because we are in a learning curve kan. Kita masih sedang akan belajar. So wrong, rights, nanti dulu. Yang penting you punya semangat ni. Alright. So don't forget to attendance tadi yang saya highlight ni. Syakila dah ni Akira, Liana, Syakila. Dah kalau dah semua okay, insyaAllah, Alhamdulillah. Right, so that's it I think. Thank you very much. Take care. See you next week.
Thank you, Doctor.
Okay. Assalamualaikum.
Thank you, Doctor.
Bye.